if you're ready to move on, we can now start looking at the next part, which is chemical formulae and chemical equations. I'm not going to read through all this because there's quite a lot there. In fact, there's too much there for this one lesson, I think. So what we're going to do is focus simply on these little bits in red at the top here. We're going to leave these bits at the bottom for a subsequent lesson. Okay, ready to start. Now, using chemical symbols. We know from all the work done so far on the periodic table that each element is represented by a different symbol. For example, Fe is for iron, Na is for sodium, and O is for oxygen. You notice that sometimes you get simply the first letter or two of the word, so oxygen using O, straightforward. But what is this about? Fe for iron, Na for sodium. Well, sometimes we use perhaps the Latin of it. So Latin for iron is ferrous, and the symbol first two letters Fe. So Fe is iron from Latin. Na is, haven't got a clue. I suggest you look that one up. I don't know why it's Na for sodium. Look it up and tell me. Now all of these symbols are in the periodic table that we've already come across. Now we can use these symbols to show molecules of compounds. They can show us a ratio of different elements which combine to form compounds. Okay, bit of a mouthful, let's go back. We can use symbols, okay, to show molecules of compounds, and they can show us the ratio, that is, numbers of different elements which combine to form compounds. Hope you're not confused. Let's have a look. H2O. Remember that one? Water. CO2. Carbon dioxide. NH3. Ammonia. Now, let's just recap what we looked at earlier, shall we? Did a bit of work on this earlier in this lesson. Sodium hydroxide. There is the formula. We know from that we've now got one atom of sodium, one oxygen, one hydrogen. Calcium carbonate. We know we've got one calcium, one carbon, three oxygens. Couple more. Magnesium nitrate, Mg. Now look, a bracket. Woo. So we've got two nitrogens, 2 times 3. We're not adding, we're multiplying. 2 times 3. Hello. That is 6 atoms of oxygen. Last one. Oh my goodness. Talk about making it difficult for ourselves. Look at this one. Aluminium sulfate. 6 atoms of aluminium. 3 times 2 is 6. 9 atoms of sulfur. Hang about. I think I made a mistake there, don't you? 3, it should be 9. It should be 3, shouldn't it? God dear, what a mistake to make. 3. Cross it off. It should be 3 sulfurs. Oh no, I know why. Oh dear. Dummy. It's 3, isn't it? Times 3, which is 9. I knew I had it right. You should have told me. 3 times 4 is 12. Oh, I know, it's 3 at the front. So it's 3 times 12 is 36. Okay. Now sometimes you've got to stop me and say, what am I talking about? So I've got 6 atoms of aluminium. 6 there. 3 times 2 is 6. 9 atoms of sulfur. 3 there times 3 is 9. 4 times 3 is 12 times 3, 36. Okay, I'm going to climb out of Mr. Stupid corner now and get on. Now hopefully you've done all these now and you're pretty familiar with them and it's no problem. Let's move on. Oh. Recognise this? This is behind this fancy label here. This is a jar of Marmite. You know the old saying about Marmite? Either love it or you hate it. The same goes with equations. People either love them or they hate them. I wonder why. Now, in any chemical equation, all you're showing is what's reacting and what's being produced. Okay? So, look at this reaction. Is sodium, you might have seen this, reacts with water very violently, fizzes away, and produces sodium hydroxide and hydrogen. So, these here are the reactants, these here are the products. This is what's produced. Okay, it's produced. Now, let's put in the symbols. Sodium, Na. Water, H2O. Sodium hydroxide, NaOH. Hydrogen, H2. Now, what this is the balanced equation. Look at it. I'll explain why in a moment. 2Na gives 2H2O, gives 2NaOH plus H2. And also we've got to put in these little things here. These are called state symbols. Okay, state symbol tells us if it's a solid, liquid, aqueous solution or gas. Now it just so happens in this equation here you've got all four. So sodium's a solid, water is a liquid, it's the only liquid you'll really come across. NaOH is an aqueous solution, and hydrogen you probably know is a gas. So you need to know your state symbols. So copy these down, highlight them, underline them, or whatever it takes. S stands for solid. L is liquid, which tends to be only water. Now other things, sodium hydroxide is normally dissolved in water. Aqua means water. So an aqueous solution is where it's dissolved in water. AQ, aqueous solution. G, obviously gas. Now you need to be able to write equations, so follow these things. Write word equations when required. Recall formulae of simple covalent compounds. Whoa, hang about, go back a word. Covalent, what's this? Well, don't panic, we'll come to this probably next lesson. Okay? Write down the formula of simple ionic compounds. Similarly, we'll come across this thing ionic next lesson. Interpret chemical formulae of molecules. We can do that. Interpret symbol equations, including state symbols. Remember those, don't we? Remember what they are? We've got those sussed now. Now let's just give you a few formulae. Now these are the formulae of simple covalent compounds. Now, at the moment you don't need to know why it's 2 hydrogens and 1 oxygen, okay, or 4 hydrogens and 1 carbon. You don't need to know at this moment in time. We'll cover this later on. But it's well worth to remember some of these common formulae. So water, H2O, carbon dioxide, CO2, ammonia, NH3, hydrogen, H2, oxygen, O2, nitrogen, N2, sulfur dioxide, SO2, methane, CH4. Now notice some of these are, as it says on the tin, sulfur dioxide, and so on. We've got a few common names here though. Look at water. You think that'd be, that's what, hydrogen oxide or something, isn't it? Well, we call it water, common name. Ammonia, you could say, that's nitrogen hydride, but it's not. Common name ammonia. And down here, methane, gas, carbon, hydrogen. So try and learn these. Okay, try and remember these. Those are covalent formulae. What about some ionics? A few more here. What have we got? Sodium chloride. Notice when it's the non-metal bit here behind a metal, the ending changes to IDE. So calcium chloride. Magnesium oxide. Okay. Now this is a familiar name here for hydrochloric acid. You need to know your acids. There's hydrochloric, sulfuric acid, H2SO4, nitric acid, HNO3. Notice in each case they've got hydrogens. Okay. Now the OH group, OH is the hydroxide group. So sodium hydroxide, potassium hydroxide, calcium hydroxide. CO3 is carbonate. The ATE here tells you there's oxygen present. See that? So carbonate is carbon oxygen. Aluminium oxide, just the oxygen present there, it's just oxide. Iron oxide, Fe2O3. Remember, you don't need to know at this point where these have come from, but in the short time I'll show you how to calculate these yourselves. Okay? Okay, right, we're now going to write balanced equations. Warning, writing balanced chemical equations can be good or bad for your health depending on your approach to them. We're going to make sure that it's good for our health by following a few basic rules. Let's have a look now. Basic rule, golden rule, numero uno, number 1. Basic rule, okay, so it's important, so put it in a big bold box and highlight it. Let's take our equation. Hydrogen plus oxygen gives water. Very straightforward, do you think? What's this? Warning sign, learning point. Woo, let's go back a second. Notice hydrogen's always H2, oxygen's always O2. So what's this saying? Gases like hydrogen H2 and oxygen O2 what we call diatomic. Okay, they like to go around in pairs. So hydrogen H2, oxygen O2, nitrogen N2, chlorine Cl2. They're diatomic. They go around in pairs. Got it? Now, what have we got here? Let's look at how many atoms. You now know from our work on formulae how many atoms we've got. We know we've got 2 hydrogens, 2 that's not 20, it's 2 O's, okay, before you ask. 2 O's, because we've got 2 oxygens. 2 hydrogens there, but whoa, hang about. That's not a 10, by the way, that's a 1 oxygen. Not a 10, 1 oxygen. Now I've got a problem here because this is a golden rule. There must be equal numbers of atoms of each element on both sides of the equation. So we're okay with hydrogen, 2 there and 2 there, hunky-dory, no problem. But look, 2 oxygens there, only 1 there, bit of a problem, isn't it? This is where balancing equation comes in. That equation is wrong. So what we could do, now we need to get some more oxygen. So if we put a, this is what we got here. This is what we've done. If we put a 2 there, 2 oxygens, fine. Oh, I know what we've done. We put a 2 there. We've now got 2 oxygens there, 2 oxygens there. So that's great. Happy. But by putting a 2 there, it means we've also now got 4 hydrogens. So come back over here. We need 4 hydrogens here, but a 2 in front. Now, warning. You cannot change the formula. The formula of water is H2O. It doesn't matter whether you're here or in Australia or on Mars. Is there water on Mars? It doesn't matter. It's H2O. You can't change the formula. All you can do is put numbers in front. So what do? Just go back a second. Now we know this is wrong because we haven't got enough oxygens. So what we did, we put a 2 in front. Now gives 2 oxygens there. Okay, 2 oxygens there gives us a total of 4. That's balanced. But by putting a 2 there, we had to put a 2 over here to make sure we had enough hydrogens. So 2H2, O2, 2H2O. 4 hydrogens, 2 oxygens, 4 hydrogens, 2 oxygens. That looks pretty good to me. Are we right? Yes! Hey! Give yourself a high five. That's right. We've got a balanced equation. Wow. This is good stuff. Now, there are 4 important steps in writing a balanced equation. Write these down, okay? Put on a big bit of paper, highlight them, put on your bedroom ceiling and look at it and wake up in the middle of the night. No, don't do that. First of all, write a word equation for the reaction. Show you that in a minute. Secondly, put in the formulae for the elements or compounds. You can now do that. Thirdly, balance the equation. Put numbers in front. Remember, we can't change the formula. In front of reactants and products where necessary. And complete the balanced symbol equation using state symbols. Ready for an example? Here we go. Example numero uno, number 1. Magnesium plus oxygen. This is a word equation. Gives magnesium oxide. You now know these formulae. So look, shall we? Mg plus O2 MgO. Oh, there's our warning. My word. Gases like hydrogen H2 and oxygen O2 are di. Remember di? Di is 2. So it means 2 atoms. Diatomic is 2 atoms. They like to go in pairs. So there's O2 in pairs. Got it? Hope you have now. Now let's count how many atoms we've got. We've got 1 magnesium, 2 oxygens, 1 magnesium, 1 oxygen. Balanced? No. What are we going to do? Well, so shall we? Remember we had 1, 2, 1, 1. So if we put a 2 in front here, we've now got 2 magnesiums and remember 2 oxygens. Hooray! So 2 there, 2 there. The oxygens are happy. But we've got to make sure we've got enough magnesiums. 2 there, but 2 in front there. We've now got 2 Mgs there. Alright? Don't follow this. Go back and check it again. Lastly, put in the state symbols. We've got 2 Mg solid, O2 gas, 2 MgO solid. Follow it through. Another example? Why not? Okay, here nitrogen plus hydrogen gives ammonia. N2, remember, diatomic. H2, diatomic, gives us ammonia. I gave you that formula earlier. What have we got? We got 2 nitrogens, 2 hydrogens, 1 nitrogen, 3 hydrogens. Right, let's look at nitrogens first of all. 2 there, 1 there. What can we do about it? Well, we can't change the formula. We need 2 of these. Let's put 2 in there. Okay, imagine a 2. Little 2 there, little 2. So now we've got 2 nitrogens. But look, we've got 2 there. It makes that 6, doesn't it? Because 2 times 3 is 6. So we need 6 hydrogens here. We've got 2 at the moment. What can we do about it? We need 6. Well, yes, you see it? Put a 3 there. 3 times 2 is 6. So we go N2 plus 3H2 gives 2NH3. It should be balanced. So look. Hey, how about that then? Look at that. 6. Whoa. Whoa. And let's put the state symbols. There we go. We have just written a complete balanced equation. Hey, let's give ourselves a pat on the back if you're a contortionist. Okay, so we've now balanced a chemical equation. That is stunning. That is amazing. Woo. I need to sit down after that. Okay, this is the end of lesson 2. In this lesson we've covered relative form mass, chemical formulae and chemical equations. Now, if there's anything you do not understand, go back to the video, rewind, pause, go over it again and again and again. Okay, no excuses. Okay, so look forward to seeing you now in lesson 3. Goodbye.